Kia ora, Year 10. This is the second video going over the JAFpractice for Algebra, and these are the relational questions. So I'm just going to show them to you quickly. Some of you watching this will already have done this JAFpractice and be using it to go over any trouble spots. Others will be wanting to try it for the first time. So we've got 9 questions that we're going to look at. And in all of these you're going to have to link some of the separate skills together. So number 18 is this. We've got 5x to the power of n times 4x squared is equal to 20x to the power of 7. And we're told to find the value of n. So all we really have to do is to simplify the left-hand side and have a look at it. So we've got 20x to the power of n times x squared, and that equals 20x to the power of 7. So what number does n have to be? Well, we know that if we've got the same base, then we just add the powers. So just looking at it, if n equals 5, it's going to work out. There's a slightly more elegant way to do it, and I'm going to show you that now. But the answer is that n is 5. So let's just get rid of that. We know from when we were working with separate skills that if we've got the same base, we can just add the powers. And we can do that here. We've got n and we've got 2. So that gives us n plus 2. And so now again we can see that we've got n plus 2 has to equal 7. So we can write that down. N plus 2 is 7 and n equals 5. It's just a slightly different way of thinking about the same thing. Oh, now why did I start? Oh, that's question 18. Right, good. Okay, question 19 is a square rooty one. If you're in my Year 10 class this year, we've done quite a few of these, and there was a good Education Perfect module on them as well. So let's have a look at what this is going to give us. We've got the square root of 36 times x to the power of 16. So the square root of 36 is 6. And then I have to ask, what's the square root of x to the power of 16 going to be? And it's x to the power of 8. Now I think I would put a couple of dollars on several of you having put x to the power of 4. Our brains want to do 4 because 4 is the square root of 16. But it doesn't work. Right? So let's look at why this is going to give me the right answer. If I take 6x to the power of 8 and I square it, that's the same as 6x to the power of 8 times 6x to the power of 8, which gives me 36x to the power of 16, because I add the powers when I've got the same base. Okay, so we'll do one more of those. We've got 100x to the power of 50. The answer to that one's going to be 10x to the power of 25. Alright, number 20. So this is a division one, but we have to do some simplifying first. 12x squared over 2x squared. Well, we'll work with the denominator first. So we've got 12x squared divided by 4x squared. Well, x squared divided by x squared is just 1, so I'm left with 12 over 4, which simplifies to 3. Right, where am I up to? Let's see, on to question 21. So with some of these, there are different ways that you can do them. So here I could look for things that I could simplify across the fraction. I'm going to come back to that method. Most students don't usually like it to start with. And the easiest thing to do when you're beginning is to multiply the numerators and multiply the denominators. So multiplying the numerators is going to get me 4a cubed b to the power of 4. And then multiplying the denominators will give me 12a cubed b cubed. Now I'm in a position to simplify. I can see that the a cubed divided by the a cubed gives me 1. 4 divided by 12 gives me a 1 up here and a 3 down here. And b to the power of 4 divided by b to the power of 3 is just b. So when I clean all of that up, I'm left with b over 3. So we don't write the 1, right, because we only do that as a placeholder in algebra. So I didn't really need to write this 1 here, but I find that students don't like, if you're simplifying 4 over 12, they like to put that 1 in. So there you go. So my correct answer here is b divided by 3, or another way to write that is just 1/3 times b. Now I'm going to look at this by seeing what simplification we can do to start with. So just get rid of all the mess here. So because I'm multiplying fractions, what can I say here? Well, I've got a squared here, and I've got a cubed here, and a here. I've got some simplifying that I can do in here, but the most obvious simplifying that I can do across the fractions is this b to the power of 4 divided by b cubed. So I'm going to do this really slowly so that you get the idea of simplifying across the fractions. So you can see what I've done here is that this b cubed and this b to the power of 4 have a b cubed in common. So I've divided through by that. But now there's a whole lot more that I could do with this, right? So this could become 2/3 here. And then I've got a here and a squared here. So I've got 2a squared b over 6a squared. But in this case, it was actually just as good to multiply the numerators and multiply the denominators. It really depends on the question. Sometimes if you've got really big coefficients, it makes sense to use this strategy. But it's up to you. We just want you getting used to seeing both of them. Okay, right, next one. Oh, the next one is a substitution. And it's one where we have to be a wee bit careful about BEDMAS. So when I do a substitution question, we start by writing out the algebraic expression, and then we substitute in our numbers. So a is 3 and b is 4. So we're going to go 3 take away 2 times 4 squared. First we work out what's inside the bracket. So this is 3 take away 8 squared, which is equal to -5 squared, and that means -5 times -5, so my answer here is 25. Right, now we've got 4 questions that are all about expanding and factorising. With the expanding ones, we have to simplify our answer. So we should be thinking at that point about like terms. So 2 times x plus 1 plus 3 times x plus 2. So expanding out this gives me 2x plus 2 plus 3x plus 6. Now when I collect the like terms, I get 5x plus 8. Right, next one. 4x times 3 plus 2x minus 2x times x minus 6. So in here what I have to be careful about is this minus sign here. Let's expand out these brackets first. We get, 12x plus 4x times 2x gives me 8x squared. Now we have minus 2x times x, so minus 2x squared. And I'm multiplying this one. Let's change pen colour. This one here times -6. So a negative times a negative is a positive, and I get plus 12x. Right, we have to clean all of that up, so we're looking at our like terms. Well, we've got, first of all, 12x here and 12x here. That gives me 24x plus 8x squared minus 2x squared plus 6x squared. Okay, it's fine to write it that way around, or you could write it the other way around. What have we got left to do? Okay, 2 factorised ones. When you're factorising, always check the coefficients and the constants for common factors in the numbers, and then I like to work alphabetically with the variables. So 12a squared plus 36a minus 18ab. Right, numbers first. Our highest common factor is a 6. Now the letters. We've got a squared, we've got a, and we've got a. The highest common factor will be a. And there's no b squared or b stuff here, so that's as good as we can get. 6a times what will get me 12a squared? 6a times 2a. Plus 6a times what will get me 36a plus 6. Lastly, 6a times what will get me this? Well, it has to be minus 3b. Right, what's left? One more. Okay, another factorise. Let's clean up the whiteboard. Exactly the same idea. We're looking for the highest common factor in the numbers, and then in the variables. Make it a bit smaller. So first of all, the highest common factor in the numbers, we've got 4, 2 and 12. Well, it will be 2. Now we look at the w's. We've got w squared, w and w squared. So we have got a w common factor, and we've also got a z, and a z squared. So it's 2wz. What a mess. We'll just take away the green stuff. Right, 2wz times 2w minus 1, right, because I have 2wz is my common factor already. Lastly, I want to have minus 6wz. Okay, so there we go. We can check that back by expanding it and making sure that we get the right thing. Now I think that's all the questions on the relational ones. Yep, it is. So I'm going to do the extended abstract in a few minutes' time. Thanks for watching.